Today we're going to be working on another type of factoring, which is known as factoring difference of two squares. A lot of times this gets shortened down to and is referred to as dots factoring. I know I have a tendency to say that a lot. So difference of two squares is the difference, which difference means subtraction. So you have a subtraction problem here of two perfect square monomials. So it's one term minus one term, and those two terms are both perfect squares. So the coefficients must be perfect squares. And the variables must have even exponents. So looking at our examples, x squared minus 9, this one right here, even exponent, so that is a perfect square. 9 is a perfect square because it's 3 times 3. Looking at a little bit more advanced of an example, 36 and 64, those are both perfect squares, and then your exponents on your variables are both even. It doesn't matter that they're different variables, it's just the fact that they are even exponents on those variables. So what we do is, step one, you're going to find the square root of any coefficients. So we're going to use the 25 and the 29. So we're going to find the square root of 25, which is 5, the square root of 49, which is 7. So again, that's step number one. Step number two is to find the square root of the variables by dividing the exponents by 2. So the square root of x squared simply means I'm going to take this 2, divide it by 2. So I would get x to the first. But remember, we don't always have to write that 1, but that is what we have there, is an x to the first. So then step 3, the way we write our final answers is there's going to be 2 sets of parentheses with the square roots with opposite signs. So what I mean by that is my first term here, 25x squared, the square root of 25 was 5, square root of x was x. So I'm going to write the square roots right there. And they're going to go first in the parentheses because my 25x squared was my first term that I was trying to factor. And so then 49, square root of 49 we found to be 7, so 7 is going to be the second term in both sets of parentheses, and just one is positive, one is negative. That's always the way it ends up going. You always have one positive and one negative with these. So again, we would check by distributing, so 5x times 5x would be 25x squared. 5x times negative 7 would be negative 35x. 7 times 5x would be positive 35x. 7 times negative 7 would be negative 49. And so then this 35 here and the negative 35, those would cancel each other out. So we're just left with 25x squared minus 49, which is in fact what we started with. So these right here, 5x plus 7 and 5x minus 7, those are our factors. So this is a factor. This one is our factor. And so that's the way we factor our dots, difference of two squares methods. 2 sets of parentheses, square roots of both terms, one's positive, one's negative. So let's practice this. So number one, remember we're going to take the square roots of these. So the square root of x squared, divide those exponents by 2, so I get x to the first. Square root of 1 is 1. So I'm going to have x plus 1, x minus 1. Square root your perfect squares. So looking at our second one, again, I'm going to take my square roots. Square root of 9 is 3. Divide my 6 by a 2, so I get x to the third. Square root of 36 is 6. So 3x cubed minus 6, 3x cubed plus 6. And it does not matter which order those go in, whether the minus first or the plus is first. It doesn't matter as long as you have both of them there. And so that's what we're doing for our dots factoring. When you got two perfect squares, square root both terms. So square root of 4 is 2. Divide the 2 by 2, so I get x to the first. Square root of 81 is 9. Divide that 2, so I get y to the first. So 2x minus 9y and 2x plus 9y. Now, number 4, they changed the order a little bit. We're used to seeing our variable first, but they put it second, and that's okay. Method is still going to be the same. I'm going to take the square roots. Square root of 16 is 4. Divide my exponent by 2, so 4 divided by 2 gives me y squared. We do have to keep it in the same order. So my 4s are going to go first because my 16s went first. So 4, plus y squared, and then minus y squared. Number 5, same thing. We get x and 10 because we divide exponents by 2. Square root of 100 is 10, so we get x plus 10, x minus 10. Same thing with that next one. So this is going to be 5y and 11. 5y minus 11, 5y plus 11. Number 7, same thing. Square root of 64 is 8. Square root of 9x to the 4th would be 3x squared. So 8 minus 3x squared, and then 8 plus 3x squared. And again, plus and minus, it does not matter which one comes first, as long as they are both there. 8, square root both sides, I get y and 12. So y plus 12 and y minus 12. So I get here down to number 9, and I try to do my square roots, but 2 is not a perfect square, and 50 is not a perfect square. So now I'm going to do a little thinking here. Now, 50 is an even number. I can divide it by 2, and I can divide my first one by 2. So we're going to do a GCF factor of 2 first. So remember, we divide, so that's going to be x squared minus 25. So I divide those first by 2. Now I have two perfect squares. X squared is a perfect square because it's an even exponent. 25 is a perfect square. So I would have x minus 5 and x plus 5 with that 2 out in front. That 2 has to stay there. All right. So what I want you to do is I want you to try those next 2 practice pages, and then I want you to check in with me, see how you're doing.